Physicists say that the universe had its origin in an event known as the Big Bang, around 13.7 billion years ago. However, the question that arises is, what caused the explosion, and why? Over time, we have been researching and studying the science and history of our universe, and the Big Bang has been the predominant explanation for everything we have observed. There have been countless studies, and thousands of scientists have worked on the research. The data collected has consistently supported the Big Bang theory as the main reason for the way the universe was formed. According to this theory, dark energy, an additional type of energy more abundant than galactic energy, is responsible for the continued expansion of the universe since the Big Bang. It is believed to be the force that prevents gravity from pulling everything back together. Science today is very different from what it was in the past. With technological advances, new theories emerge. Many times, we discover that things we believe to be true in every way are far from being so. Recently, attention has turned to the official debunking of the Big Bang theory. This is due to the James Webb Telescope, which has detected 750 new galaxies that look nothing like what was anticipated. This raises a new perspective and leads us to delve deeper into how the James Webb Telescope is changing our understanding of the universe as a whole. Join us on this incredible journey beyond the far reaches of the observable universe to discover more details about the immense number of new galaxies that have been discovered. If you are interested in keeping up to date with news from the universe and its surroundings, subscribe to our channel. Be sure to like this video, share it to reach more people, and turn on the notification bell. The images of new galaxies captured by the James Webb Telescope are absolutely stunning. In a single image, we can see hundreds of galaxies as a whole, showcasing their beauty. These photos have incredible power, something that cannot be overlooked. However, what seems to amaze the average person is precisely the opposite for researchers. These images are amazing to them, but they do not match what scientists expected to see based on their theories. There are more galaxies visible than expected, and these galaxies are different from the rest. They are smaller than imagined and have a truly remarkable age. These surprises are generating some panic among scientists. There is even an article that begins with the word panic in its title, which shows the seriousness of the situation. These galaxies are nothing like what they were supposed to be, according to established theories. For a long time, scientists have proposed the Big Bang theory as the main explanation for the origins of our vast universe. According to this theory, approximately 13.7 billion years ago, the universe began its existence through some kind of mysterious cosmic event. However, these new images challenge the definitive story of the birth of the cosmos. As previously understood, these striking images captured by the James Webb Telescope have challenged our understanding of the origins of the universe. Specifically, these images directly contradict the Big Bang hypothesis, which has been considered unquestionable by the majority of cosmology theorists. The galaxies captured in these images appear to be too small, smooth, old, and numerous compared to the predictions of the Big Bang hypothesis. The fact that the observed galaxies are 2 to 3 times smaller than those imaged by the Hubble Space Telescope completely defies the expected behavior in an expanding universe. According to the hypothesis, as the universe expands, objects should appear larger as distance increases. However, these James Webb observations show galaxies that defy that expectation. Moreover, the smoothness of these galaxies is totally unexpected. According to the Big Bang theory, galaxies should show irregularities and changes in their structures as a result of the dynamics of their formation and evolution. However, the images reveal unusually smooth galaxies, without the level of complexity and roughness that one would normally expect to see in galaxies of their age. This defies the expected time sequence for the formation and development of galaxies within the framework of the Big Bang theory. At the beginning of the universe, all matter, energy, and the building blocks of the cosmos were compressed into an extremely concentrated point called a singularity. The density at this point reached an infinitely high value due to the extreme compression of matter and energy. The concept of singularity is based on our current understanding of the laws of physics, especially the equations of general relativity proposed by Albert Einstein. Within the singularity, all the universe's energy and matter existed in an extraordinarily compressed form. This high density suggests that an enormous amount of energy and mass was concentrated in an infinitesimal space. Under extreme pressure and density conditions such as those present in the singularity, heat would be unimaginable. The temperature within the singularity would exceed any temperature observable or reproducible in our current understanding of the universe. The energy stored in this hot, dense point was the seed from which the entire universe as we know it originated. The singularity marked the beginning of the universe, the origin of everything in our cosmos. After the initial singularity, the universe began its expansion journey and inflation. This process occurred over an incredibly brief period of time, mere fractions of a second, but it was enough to expand the universe from a subatomic scale to astronomical proportions. This rapid inflation laid the groundwork for the distribution of galaxies, matter, and cosmic structures that we observe today. Following this inflationary period, the universe continued to expand, though at a slower pace. Temperatures gradually decreased, allowing particles to combine and form simple atoms, primarily hydrogen and helium. This era is known as the recombination epoch, during which light could finally travel freely through space, creating what we now detect as the cosmic microwave background radiation, a crucial piece of evidence supporting the Big Bang theory. Over billions of years, gravity pulled together matter to form stars, galaxies, and eventually, complex systems such as our solar system. The formation of elements through nuclear fusion in stars, supernova explosions, and the emergence of planetary systems became the building blocks of the observable cosmos. However, the data collected by the James Webb Space Telescope has introduced significant anomalies to this established narrative. The newly observed galaxies are not only smaller and smoother than anticipated, they also appear to be far older than the age of the universe would seemingly allow if the Big Bang timeline were strictly accurate. These galaxies appear mature and well-formed, as though they had billions of years to evolve, which contradicts the idea that the universe was once devoid of structure shortly after the Big Bang. This paradox has led scientists to re-evaluate the timing and mechanisms behind early galaxy formation. Some now speculate whether the Big Bang theory requires revision, or whether an entirely new cosmological model is needed to explain the universe's origin and early development. Alternative theories such as the steady-state model, cyclic universe theory, or even speculative quantum gravity frameworks are gaining renewed attention, though none yet rival the Big Bang in terms of empirical support. Despite the controversy, what is clear is that our understanding of the universe is evolving. The James Webb Telescope is not disproving science, it is doing exactly what science demands, challenging assumptions, presenting new data, and compelling us to refine our theories to better match observed reality. As we venture deeper into space and further back in time, we must be prepared to encounter the unexpected. Each new discovery reshapes our cosmic narrative and pushes the boundaries of human knowledge. The universe is vast, mysterious, and often paradoxical, but through the lens of innovation and inquiry, we continue to explore its secrets. Stay tuned as we uncover more from the James Webb Telescope and other groundbreaking missions, which together may redefine our very concept of time, space, and existence itself. Roughly 13.7 billion years ago, the universe as we know it began to take shape. The expansion of the universe started with a remarkable and swift burst known as cosmic inflation. During this phase, the universe expanded at an unimaginable speed, far exceeding the speed of light. It was as if the very fabric of space pulled, stretched, and expanded everything within it. Cosmic inflation played a massive role in the creation of the universe's large-scale structure. It made the universe more even, irregularities were homogenized, and the distribution of matter and energy was smoothed out. This process paved the way for the subsequent formation of galaxies, stars, and other cosmic structures. As the universe continued to expand, the rate of expansion gradually slowed. It is important to note that although there was rapid cosmic inflation during the initial period, the universe continued to expand at a measurable rate thereafter. This steady expansion is what scientists refer to as cosmic expansion. Scientists have observed the effects of this expansion through various methods, such as the redshift of light from distant galaxies. Redshift indicates that, as the universe expands, light waves are stretched and shifted to longer wavelengths, moving them toward the red end of the spectrum. During the early stages of expansion, all the matter that makes up our universe was compressed into an incredibly small volume. In such a compact state, matter could not survive. So, as the universe expanded and cooled, changes took place throughout. Particles such as protons, neutrons, and electrons began to interact with the surrounding light and energy. These interactions played a key role in the formation of matter in the universe during the first minutes after the Big Bang, a process known as nucleosynthesis. It was expected that chaotic and disrupted galaxies would be observed due to multiple collisions. However, the story told by the James Webb Space Telescope, JWST, is different. Instead of chaotic galaxies, the images reveal well-organized disks and spiral structures, similar to the galaxies we observe in the universe today. This unexpected observation challenges the idea that mergers are a common process in galaxy evolution. If these new galaxies have not experienced many, or any, mergers, it becomes unlikely that small galaxies grow into massive ones hundreds of times larger, as previously believed. This implies that these galaxies may never have been small in the first place. Furthermore, the optical illusion predicted by the expanding universe hypothesis, where objects appear smaller due to expansion, does not hold in this case either. Therefore, what we have believed so far may turn out to be incorrect. In addition, the age and abundance of galaxies revealed by the James Webb Space Telescope also challenge the validity of the Big Bang theory. The JWST is equipped with filters that allow imaging in the infrared part of the spectrum, which facilitates the study of distant galaxies. By analyzing these colors, astronomers can estimate the age of stars and galaxies. I hope you enjoyed this video. If you did, don't forget to hit the like button, share this video to reach more people, and subscribe to the channel so you won't miss our next upload. The discoveries made by the James Webb Space Telescope have not only expanded our understanding of the universe, but have also raised fundamental questions about the models we've relied on for decades. If galaxies formed earlier, were more organized, and more massive than previously expected, this forces us to reconsider the timeline of cosmic evolution. Moreover, the presence of mature galaxies at such early stages suggests that either star formation occurred much more rapidly than our models predict, or that the universe itself might be older, or at least more complex, than the standard Big Bang framework accounts for. Another point of contention is the cosmic microwave background radiation, long considered the afterglow of the Big Bang. While it remains a crucial piece of evidence, some inconsistencies have emerged when compared with JWST data. These contradictions prompt scientists to ask whether the Big Bang is the complete story, or just one piece of a much larger cosmic puzzle. Alternative theories, such as the steady-state model, cyclic universe models, or even multiverse hypotheses, are being revisited with renewed interest. These ideas propose that the universe has no singular beginning or end, but instead undergoes perpetual phases of expansion and contraction, or that our universe is just one of many. What's clear is this: with every new image, every data point, and every unexpected anomaly, the universe is speaking to us. And the message is loud and clear: we still have much to learn. As we continue to peer deeper into the cosmos, we must be willing to question even our most established beliefs. Scientific progress thrives on skepticism, on the willingness to revise theories in light of new evidence. The universe is not static, and neither should our understanding of it be. So, stay curious. The story of the cosmos is still unfolding, and we are lucky to be here to witness it.